So we are on section 7.1, which is the square root property and completing the square. So the square root property is so useful. What this is saying is if you have a number, let me just get my pen ready for us. So if you have a real number, k, and if we're told that x squared is equal to k, well, then we know that plain old x is equal to the square root of k, but it's also equal to the negative square root of k. And so instead of writing those x's separately, what we often do is just say that x is equal to both the positive and negative roots of k. So let's look at this example real quick. To use the square root property to solve this equation, where we've got 2x squared equals 50, what we're going to do is we are going to divide both sides of our equation by that coefficient of 2. And so then we're left with x squared is equal to 25. To find all of the x values that could make that a true equation, we are going to take this, look for both the positive and the negative roots of square root of 25, and that's how we get x is equal to plus or minus 5. So the how-to. So how to apply the square root property. Number 1, isolate the variable. Then number 2, you're going to take the square root of both sides. Then number 3, you are going to include both the positive and the negative roots. Oops, there's no E there. Both the positive and the negative roots. Okay, so let's go ahead and look at this first example here. X squared is equal to 144. So if I rewrite that, x squared equals 144. Now I'm going to go ahead and take the square root of both sides. On the right-hand side, I'm looking for both the positive and the negative roots. So on the left side where we have our variable, now we've got an exponent that equals our index. We know what happens when we have that. That's going to allow our radicand to kind of fall out. And so we've got x is equal to plus or minus 12. That one's done. All right, let's look at b. So for b, we have to first isolate that variable of x squared. And we do that by subtracting 5 from both sides. So I'm going to subtract 5, and so I get x squared is equal to 16. Now I want to go ahead and take the square root of both sides, looking for both the positive and negative roots. And so that's just going to leave me with x is equal to plus or minus 4. So that means that if I take both a positive 4 and a negative 4 and plug them in for x, I'm going to get true statements. I'm going to get the same number on both sides of my equation. Let's go ahead and look at c. C looks a little different. It's fine. It's not that different. We're going to approach it the same way. I'm going to go ahead, subtract 5 from both sides. So then I have the quantity x minus 1 squared is equal to 225. So I'm going to do the same thing. I'm going to take the square root of both sides, looking for the positive and the negative roots of that 225. So then that radicand is just going to come out from underneath that radical sign. So I've got x minus 1 equals plus or minus 15. But I don't have that x all by itself yet. I need to add 1 to both sides. When I add the 1, I'm being very purposeful. I'm putting it in front of that plus or minus. So now I've got x equals 1 plus or minus 15. Well, that's giving me two values for x, okay? So over here, I'm going to solve and get those two values, kind of pull them out here. It's 1 plus 15, which is 16, and then 1 minus 15, which gives me a negative 14. There we go. All right, now let's look at D. So I'm going to go ahead and I am going to subtract 7 from both sides. So I get x squared is equal to a negative 36. So now I'm going to take the square root of both sides, looking for both my positive and negative roots. On the left side of my equal sign, I just have an x. Now, before, I would have stopped right here and said, oh, I've got a negative underneath my radical. When I have an even index, I can't do anything. But since we learned about complex numbers and imaginary numbers, we can deal with this. This, I'm going to pull out an I, okay, because negative, remember, negative 1, the square root in negative 1 is equal to I. So I'm going to pull out an I, and then the square root of 36 is 6, so I get plus or minus, I'm going to change right there, 6I. And that's my answer. All right, let's go ahead and do D. I'm going to add 8 to both sides. So when I do that, I get a negative 4x squared is equal to a negative 36. Divide both sides by that coefficient of negative 4, and so I get x squared is equal to 9. I'm going to take the square root of both sides, looking for my positive and negative roots, and so I'm left with x is equal to both plus and minus 3. All right, last one. So this one, E, is already in my square root. It's already being squared, and it's isolated. What's being squared is isolated. So I can just start out by taking the square root of both sides, making sure I look for plus or minus square root of 17. So then I've got x plus 6 equals to, well, 17 is not a perfect square, so that's okay. I'm just going to write plus or minus square root of 17. Then I subtract 6 from both sides of my equation. And so I'm left with x is equal to negative 6 plus or minus the square root of 17. This is referred to as an exact answer. I don't have to go any further. I just stop right there. Okay? All right. So now what we're going to do, that's applying the square root property when everything is working out just beautiful. But it doesn't always work out like that. Sometimes we have quadratics that are a little more complicated. So we have to know how to deal with those. So before we start dealing with them, I want us to work on a skill, which is called completing the square. And we're going to use that skill to then solve more complicated quadratic equations. All right. So completing the square. Well, actually, let's even back up. Let's go ahead and recall that when you have a perfect square trinomial, that's what we have here, that can go ahead and we can factor it down to a binomial squared. We just take the square root of that first term, the square root of the last term, and then we use the sign between the first and the middle terms. Done. Okay, let's quickly do B. That's going to give me x plus 8 raised to the second power. Done. Okay, now, so what if we don't know that third term of our perfect square trinomial? So this third one, what if that is unknown to us? Well, then all we need to do is we can calculate that. It's going to be 1/2 times this coefficient of your B term, of your middle term, and then you take that quantity and you raise it to the power of 2. That's what's going to give you that third term. Okay, well, let's sometimes if we do it, it makes more sense. So let's look at an example here. Let's start with x squared plus 10x plus n. And so what we're interested in is finding that third term. So to find our n, it's going to be 1/2 times b squared. Well, our b is 10. So I'm going to take 1/2 of 10, which is 5. And then when I square that, I get 25. So our n is 25. So that becomes, our perfect square trinomial becomes x squared plus 10x plus 25. Well, to then factor it to a perfect square trinomial, that's just going to be x plus 5 raised to the second power. That 5 is always going to be 1/2 of that middle term. Okay, so let's go ahead and do a few of these. So I'm looking for my n in this first example here, x squared minus 12x plus n. Okay, so n is going to be 1/2 of b squared. So that's going to be 1/2 times 12. I'll put negative 12 squared. Well, and I put the 12 up there closer to the numerator because I always like to do a fraction times a fraction. So that's going to be negative 6 squared, which is a positive 36. So this would be x squared minus 12x plus 36. So to put that in factored form, so when I talk about that, I mean that perfect square trinomial that we just completed. In factored form, I'm going to have a binomial squared, and it's going to be x minus 6 raised to that second power. Okay, let's do another one of these. So to find my n, it's going to be 1/2 times that b of negative 10. I'm going to put that negative 10 over 1 and then square it. So that's going to be negative 5 squared, which is going to be 25. Negative 5 times negative 5 is 25. So my perfect square trinomial is x squared minus 10x plus 25. In factored form, this perfect square trinomial is going to be x minus 5 raised to the second power. So this minus 5 matches that 1/2 of that b term, always. All right, let's do another one. So this next one is going to be, our n is going to be 1/2 times 7/1 squared. Well, 2 doesn't go into 7. That's okay. So that's going to give me 7/2 squared, which is just 49/4. 7 squared is 49, 2 squared is 4. So my perfect square trinomial, when I substitute that n right back in, is going to be x squared plus 7x plus 49/4. In factored form, I'm going to get a binomial squared, and it's going to be x plus 7/2. Okay. All right, let's do one more of these guys. So, wow, our b term for this one is a fraction. Wow, that's okay. It's not a big deal. So, same process. I'm going to take 1/2 of that b term, that middle term. So that'll be 5/4. I take that quantity and square it. Well, I can't reduce anything. So that's going to give me 5/8 squared, which is, I take my 5 and I square it. That gives me 25 in the numerator. 8 raised to the power of 2 is 64. So that is my n, or my third term, for my perfect square trinomial. So I get x squared plus 5/4 x plus that 25/64. So now when I put this in factored form, it's going to be x plus this 5/8. All right. So notice that some of these were really easy to do. The numbers worked out real nicely, and some of them not so much. Well, let's take a peek here. So here's the observation. When your b term was even, then we got really nice numbers. When it was odd, then we got a fraction in our binomial. And when it was a fraction, then it just went all crazy, and we got a fraction there too in our binomial. Not impossible, but when you're looking at strategies in terms of solving equations, it's going to be nice to be able to look and kind of keep that piece of information tucked in the back of your head. So if you have a b term that's even, it's going to be really easy to complete the square. All right, let's go ahead and keep moving on here. All right, so we have, this is just in the yellow box, I have the steps that we need to use in order to solve a quadratic equation using this skill that we just developed, which is completing the square. And then after we complete the square, we can apply the square root property. So one of the things that's really important, step number 1, is you need to divide both sides by a so that your leading coefficient is 1. So your a is your leading coefficient. That needs to be a 1. All right, next, you just isolate the variable terms on one side of the equation. Next, you complete the square. That's what we just did. And then last, you apply the square root property and solve for x. That's what we were doing right when we began this whole video, was applying the square root property. And we are, after we complete the square, we're going to have that we're going to have a quantity in parentheses raised to the second power equal to a number. That's the format you need in order to take the square root of both sides and solve your equation. Pretty cool. Okay, this example that we have here is like, I think it gets a little messy. So I'm going to, clearly you've got it there that you can go over in detail, but I'm going to go and jump into problem number 3 and just go ahead and work through this so that you can see the steps. Okay, so first thing that we do is we notice that our leading coefficient is a 1. So we don't need to divide by that leading coefficient. It's already a 1. Okay, now what we want to do is we want to separate the variable terms from the constant term. What does that mean? Super simple. I am just going to subtract 32 from both sides. And so then I am left with my variable terms on the left. So x squared minus 12x. I'm actually going to put a plus a blank just as a placeholder. And then that's going to be equal to negative 32. And I'm going to do the same thing, plus a blank. So what goes into that blank? That's our n. That's our n. So our n, okay, is going to be 1/2 times this negative 12. And then I'm going to square it. So that gives me negative 6 squared, which is 36. That 36 goes in my blank. Because of the principle of equality, I have to add the same thing to both sides of my equation. Okay, now on the left side, I have a perfect square. I created that. Okay, that was my whole purpose. So now I can go to a binomial squared. So that's going to be x minus 6 raised to the second power. On the right side, I have a 4. So now I've got this in the format that I need in order to apply the square root property. So I'm going to take the square root of the left, the square root of the right, looking for both my positive and negative roots. So on the left, I can just shake out that radicand. X minus 6 equals plus or minus 2, because the square root of 4 is 2. So now I've got, let me just bring that over. I've got x equals, I'm going to add 6 to both sides. So x is equal to 6 plus or minus 2. That's 2 equations. It is x equals 6 plus 2, which is 8. And then x is equal to 6 minus 2, which is 4. So 8 and 4 represent our solution set. So x is equal to both 4 and 8. All right? Okay, let's try another one. These actually are fun. All right, we're going to start the same way. Right away, I notice this is going to be a little more complicated because I have an odd b. My middle term is, the coefficient is odd. No problem though. I also notice that I have a 1 as my leading coefficient. So I don't have to divide everything. I always need that to be a 1. All right, so now let's get started. We are going to separate my variable terms on the left. My constant goes to the right. So I've got x squared plus 3x plus blank equals 9, because I added 9 to both sides, plus a blank. Now I'm going to figure out what goes into that blank. It's going to be my n, I'm going to try and figure out what I need to create that perfect square trinomial. It's 1/2 times 3, really 3 over 1, raised to the second power. So that's going to give me 3/2 squared, which is 3 squared is 9, 2 squared is 4. So I've got 9/4 that I add to both sides. Beautiful. So now on the left, I can have this perfect square trinomial that I created by finding that n. So now I can just create a binomial squared. Okay, so that's going to be x plus, now I take the square root of 9/4, which is going to give me that 3/2. And that's equal to 9 plus 9/4, which is 9 and 9/4. So that'd be 36. I take 4 times 9, okay, which is 36 plus 9, and that's going to give me 45. So I've got 45 over 4. I can go ahead, take the square root of both sides, looking for both my positive and my negative roots. So I've got x plus 3/2 equal to, plus or minus, well, let's just do a little work on the side. The square root of 45 is the same thing as the square root of 9 times the square root of 5. Well, the square root of 9 is 3, so that would be 3 square roots of 5. So I've got plus or minus in my numerator, 3 square roots of 5. In my denominator, the square root of 4 is 2. So now I just need to finish this off by isolating the x. So I am going to subtract 3/2 from both sides. So I get x is equal to negative 3/2 plus or minus 3 square roots of 5 over 2. That whole beautiful thing is my answer. Wow. Okay. All right. Let's try 5. So I look at 5. I see that I've got a b of 2, but then I have an a, or a leading coefficient, of 7. Okay, I can't have that 7. So what do? I am going to divide my entire equation by 7. All right. So I do 7, 7, 7, 7. Okay? And so that is going to give me x squared. Let me do this in black. X squared minus 2/7 x. I'm going to put here plus blank is equal to, bring that 4/7 over. So I got 4/7 plus blank. Okay. So now the good news is I have a coefficient of 1. The not so good news is my b term's a fraction. So this will be a little more complicated, but really not that much. So to find my n, it's going to be 1/2 times negative 2/7 squared. Well, my 2's reduce, so that's a negative 1/7 squared, which equals 1 over 49. So I put 1 over 49 in both of those blanks. I'm adding the same thing to both sides of my equation. So now I created on the left a perfect square trinomial that I can factor into a binomial squared. And it's going to be x minus 1/7 raised to the second power. On the right, I'm going to add those two fractions together. You can either do it manually or you can put it in your calculator. I don't care. But if you're doing it manually, you have to have common denominators. So that's going to give me 28 over 49. 28 plus 1 is going to give me 29 over 49. Okay. So now I'm going to take the square root of both sides, looking for both my positive and my negative roots. So that's going to be x minus 1/7 equals plus or minus the square root of 29 over 7. The square root of 29 is prime. There aren't any factors I can break it into that I can take a root of. All right. And so now my final answer, I just need to bring that 1/7 over to the other side. So it's going to be x is equal to 1/7 plus or minus the square root of 29 over 7. That is my exact answer. And it's really two answers. It's 1/7 plus the square root of 29 over 7 and 1/7 minus the square root of 29 over 7. Okay, let's go ahead and look at number 6. So again, I have something that's not a 1, that's my leading coefficient. So I start by dividing everything by 2. Okay? And so that's going to give me x squared minus 7/2 x plus 1/2 equals 0. I'm going to bring that 1/2 over to the other side. So I've got x squared minus 7/2 x plus blank equals negative 1/2 plus blank. I need to calculate that n that goes into that blank that's going to create a perfect square trinomial on the left. So n is equal to 1/2 times that b term, which is a negative 7/2, and then I square it. So that's going to be a negative 7/4 squared, which is 49 over 16. So that's what gets added to both sides. All right, so now on the left, I'm going to go ahead and create my binomial squared. That's going to be x minus 7/4. How did I do that so fast? Right, it's right there. I just looked over at it. Okay, and then that is going to be equal to negative 1/2 plus 49/16. I've already done the math, and I got, 41/16. All right, so now I can take the square root of both sides, looking for both my positive and negative roots. And so I get x equals 7/4 plus or minus the square root of 41 over 4, because the square root of 16 is 4. So I can simplify the denominator, but I cannot simplify the numerator. That's my answer. All right. Oh, look at number 7. 7 looks a little different. So with number 7, I've got, I'm going to go ahead and distribute that 2y first. So I've got 2y squared minus 2y equals 3 minus y. All right. I need to go ahead and I need to actually add y to both sides. And so I'm going to bring this y over. And so that is going to give me 2y squared minus y is equal to 3. I'm not going to bring that 3 over to the left because I'd just be switching it right back. But what I am a little bit, I need to be careful of is I have a 2 as my leading coefficient, not a 1. So I need to divide all of my terms by that 2, including that 3. All right, so that is going to leave me with y squared minus y over 2 is the same as 1/2 y plus my blank equals 3/2 plus my blank. All right, so now I want to calculate my n that's going to go into those blanks. I'll do that up here. So my n is going to be equal to 1/2 times negative 1/2 squared. So that is going to give me a negative 1/4 squared, which is a positive 1/16. So I put 1/16 in both of those blanks. So from there, I can go ahead and I can create my binomial squared. So that's going to be y minus 1/4 raised to the second power. And then if I add 3/2 plus 1/16, that's going to give me 25/16. You can do it with a calculator or you can do it manually. Now I'm ready. I've got this in the form I need where I've got something squared equal to a number. That's the format you need to apply the square root formula, or square root property, I mean. So I'm applying my square root property, looking for both the positive and the negative roots on the right side. So then this is going to leave me with y minus 1/4 is equal to plus or minus 5/4. I'm going to add 1/4, so y is equal to 1/4 plus or minus 5/4. Well, I can add and subtract those fractions. There's no roots there, okay? There's no radical signs. So this becomes 1/4 plus 5/4, which is 6/4 or 3/2. That's one of my values for y. And then I've got 1/4 minus 5/4, which gives me a negative 4/4, which is a negative 1. So those are my two values. Okay, let's go ahead. We've got this one. I'm actually going to do a different one. I'm going to switch this one out. And I'm going to do one that actually gives us an answer that has an imaginary number. I think that might be more interesting for you. So let's start here with 9y squared minus 24y plus 17 equals 0. All right. So the first thing we notice is we have a number or a coefficient that's not a 1. So I'm going to divide all of my terms by that coefficient of 9. Okay. And so that leaves me with y squared minus, well, 24/9 I can reduce, let's see, can I? Let me think here a minute. Actually, I can't. That's just going to stay 24/9. 24/9 y plus blank equals negative 17/9 plus blank, because 0 over 9 is 0. All right, now let's dive in. Let's figure out what goes in that blank. So my n, it's going to be 1/2 times negative 24/9 squared. All right. Well, 2 goes into 24, actually negative 24, to give me a negative 12. Now, that 12/9 can be reduced, okay? So that can be reduced to a negative 4/3 squared. So then when I apply the power of 2, it's going to give me 16/9 and 16/9. So now I've got my perfect square trinomial. I can bring that to a binomial squared. So that's going to be y minus, now if I take the square root of 16/9, that gets me right back here to my 4/3. And then if I take negative 17 plus 16, I get negative 1/9. So now I can go ahead and apply my square root property, looking for the positive and the negative roots. So on the left, this is just business as usual, y minus 4/3. But on the right, I've got this negative under my radical. Okay, not a big deal. So that's going to be, I'm going to pull out an I. So it's going to give me plus or minus 1/3 I, because the square root of 1 is 1, the square root of 9 is 3. All right, so now I'm going to add 4/3 to both sides, putting that 4/3 in front of the plus minus. So this is going to end up being, as my final answer, y equals 4/3 plus or minus 1/3 I. That is my exact answer. And my exact answer is an imaginary number. Well, that's pretty cool. All right. Pretty sure there's one like that on homework. All right. Let's look at one application. I love this application. Okay. So let me see so you can read it here. Well, the stopping distance in feet, okay, of a car traveling at a given velocity v in miles per hour is given by this formula right there. We want to find the velocity of a car that traveled 160 feet before stopping. Okay, so this right here, this 126 feet, that's our D. All right, so we're going to substitute that into our formula. So we're going to get 126. I'm going to flip this around and put my variables on the left, just because that's how we've been looking at things. So that gives me 7 over 125 v squared plus 21 over 20 v equals 126. All right. Now's where it gets a little bit complicated. All right. I need to divide by this coefficient. Seriously? Oh my gosh. How do we do that? The same way we divided by a whole number. Just now it's a fraction. So we're going to divide by 7 over 125, 7 over 125, 7 over 125. Okay, it might get a little messy, but we can handle it. All right, so that's going to be, first of all, in front of our v squared, everything goes away. So we've just got a v squared. Okay, now this 21 over 20 over 7 over 125 is just a complex number. We've dealt with those already. All right. So we can think of this as, 21/20 times the reciprocal of that denominator. So 125 over 7. So, and v. So I know that 7 goes into 21 3 times, and 20 and 125 share a common factor of 5. So 20 divided by 5 is 4. 125 divided by 5 is 25. Yeah. And so now I've got, when I multiply, well, here, let's do the same thing on the right. So I've got 126 over 1 times 125 over 7. Wow. So on that side, 7 goes into 126, thank goodness, an even amount of times, 18 times. So on my right, I've got 2,250. On the left, I've got v squared plus 75 fourths v. Well, let's put our blanks. So plus blank, plus blank. Okay? Because we're going to, in order to solve this, we're going to need to complete the square. So to find our n, you got to be kidding me, right? Our n is going to be 1/2 times 75 fourths squared. Oopsie. There, now you can see it. Okay, and so that's going to give me 75 over 8 squared. And so that is the same as 5,625 over 64. That's what goes in our blank. All right, 5,625 over 4, 5,625 over 4. This is a little messy, but it's all doable. So on the left, we're going to go ahead. We've got a perfect square, so we're going to create our binomial squared. So that's going to be v plus. Well, remember that that second term in that binomial is always whatever you had in that parentheses before you squared it. So I can bring over that 75 eighths. That's pretty cool. Now, if I add these two numbers together, I need to have common, oopsie, my 6 didn't, that should be a 64. So that is going to be, did I do everything right here? Oh yes, when I get my common denominator, this is actually going to end up being a huge number. It's going to be 149,625 over 64. That's just adding those two together. You can do that with your calculator. So now I've got it in the right format, so I can apply my square root property. Okay, so this is going to give me v plus 75 eighths, which is going to be equal to plus or minus of the square root of 149,625 over 64. All right, which is going to be roughly, at this point, I'm going to go ahead and simplify that numerator. If you put it in your calculator, you're going to have plus or minus the square root of that 149,625 is roughly 386.8, and then the square root of 64 is 8. And now I'm going to subtract. So now to get v, it's going to be 75 eighths plus or minus this 386.8 over 8. All right. Well, I can't, well, if I go ahead and first add the two, okay? So that means my velocity would be 75/8 plus the 386.8 over 8. That's going to give me approximately 38.9 miles per hour or 39 miles per hour. But the second number I get, I'd have 75/8 minus 386.88. I don't even need to do that work because it's going to give me a negative miles per hour. You can't have a negative miles per hour. So that answer won't make sense. It's going to be about 39 miles per hour. Okay. And I think, did it say, yeah, round to the, oh, it said round to the nearest tenth. So 38.9 would be my correct answer. Was that a crazy one? Yeah, but you could do it. Okay, now this next one. Find the distance for a car traveling at a velocity of 35 miles per hour. This one is not so crazy. All we need to do for this problem is they're giving you velocity. So if we go back to our original formula, D equals 7 over 125 v squared plus 21/20th v. So all we need to do is plug in 35 into each of those positions for v. So I get D is equal to 7 over 125 times 35 squared plus 21/20 times 35. It's just a calculator exercise at this point. And so you get approximately 68.6 plus 36.75. Add those together and you get about 105.35 feet. That is our distance. Not nearly as complicated. All right, so you've got enough to do your homework. Good luck. Have fun.